Welcome all. In continuation to our lectures on practice series for GATE 2025, this is the second lecture on TOM. So I have collected some very good questions, especially with respect to acceleration and velocity analysis. Let's see what questions we are trying to cover. Number 1, number 2, number 3, number 4, number 5, number 6, and so on and so forth. Let's try to do in a conceptual manner. See, I'm not saying that you are going to get these questions in examination, but the only thing is absorb concepts. Okay, let's start this session. The bent flat bar rotates about a fixed axis. Okay, this is the fixed axis. Okay, through point O. This is point O. To point O, this is rotating. Okay, the instantaneous angular properties are indicated in the figure. Determine the velocity and acceleration of point A. There is point A here and it is rotating about O. The bar is bent like this. Okay, let me redraw, my dear students. The angular velocity is given as 2 omega, omega is 2 radian per second in the anti-clockwise direction, and the angular acceleration given as 5 radian per second square, but it is in the clockwise direction. So you may be wondering, sir, this is a simple question. Why have you given this question? The same question can be asked in two ways. Simply, he may be asking you the magnitude of velocity and magnitude of acceleration, or he may be asking the velocity and acceleration in vector form. ठीक है, sirs. Let's try to do both ways. Very simple. Now, let me take the figure. Let me redraw the figure. This is O, and it is something like this. Okay. It is like this. This point is A, and he is asking the acceleration of point A. Let me check, sirs. You are check karo. A, O, and okay. The angular velocity is 2 radian per second, and the angular acceleration is alpha is equal to 5. This is also given. Now, this length, चलो इसको हटा ही देंगे, sirs. तो disturb हो रहा है ये. We know these values are the angular properties are given, so don't worry. Now, this angle is also given, and this is 15 degree. Okay, correct ना? चलो, okay, कोई बात नहीं, sirs. Now observe here. This length is given as 0.5 and this length is given as 0.3. Let me check, sirs. 0.5, 0.3, yes, 120 degree. Okay, alpha is 5. This angle is given as 120 degree. You know, my dear students, the complete single bar is rotating about this point O. Hanji. So what I do is, the simple method is, my dear students, the simple method is, एक second, मैं दूसरा line ले लेता हूँ सर, दूसरा color, okay, and let me join this. ठीक है sir. Let us try to find out this length. Once I find this length, the angular velocity is given in anti-clockwise direction. So if you understand clearly, my dear students, एक बार देखना सर, ये वाला ले लेंगे थोड़ा इसको, देखो, this one, ठीक है. How will be the velocity of A as this is rotating in anti-clockwise direction? Let's check, is it anti-clockwise direction? Yeah, omega is anti-clockwise direction. Yes, exactly. Now, so if it rotates in anti-clockwise direction, and you know very well, with respect to this point, this point A has a velocity perpendicular to this. It has a velocity perpendicular to this. Exactly. This is the velocity of A. Okay, sirs. And already omega is given. How much is that omega? It is anti-clockwise 2 radian per second. Now, how do I find this length? Very simple, sir. Let us apply cos rule. This is 0.5, this is 0.3, and the included angle is 120. So I can easily find OA. So how do I do? This is 5.5. You know cos rule. OA square is equal to, this square is equal to this square plus this square minus 2 into this length into cos of included angle. So therefore, it is 0.5 square plus 0.3 square minus 2 into 0.5 into 0.3 into cos 120. So if I calculate OA, it is turning out to be OA square is 0.49, root of that is 0.7 meter. Let me check, sir. Is it 0.7 meter? Exactly. It is 0.7 meter. No problem, sirs. Now, how to calculate velocity? V is equal to, about this point, it is rotating. About this point, it is rotating. So V is equal to, the tangential velocity V is equal to R omega. This is R. About this as a radius, it is rotating. So OA is 0.7. So therefore, the velocity of A is, this length is 0.7. And the omega of the complete system is 2. And this velocity A is equal to 1.4 meter per second. This is the answer to the first part, that is 1.4 meter per second. No problem at all. Now, ठीक है sirs. Now let's try to find out क्या बोलते हैं, the acceleration. He has acceleration also. Let me see the question. What is the velocity and acceleration of point A? How to find acceleration? Very simple, sir. At this point, you know, as it is rotating, as if this is the circle about which this is rotating. And you know, my dear students, when this rotates, please note down that alpha is given as phi. The tangential acceleration will be in the direction of alpha. Therefore, the tangential acceleration is given by R alpha. I'm using scalar approach. First, I'll use scalar approach. Then I'll go for vector approach, because we don't know what type of questions are asked. Suppose in vector form the accelerations are asked, then you'll be in problems. Chalo, what is tangential acceleration? At every point we have one normal acceleration towards the center and the tangential acceleration tangent to the circle. Okay, sir. What is R? This R is 0.7. This R is 0.7 and alpha is 5. So therefore, the tangential acceleration is given by 7 5 35. So it is 3.5 meter per second square. Exactly. And what is the normal acceleration? You know that normal acceleration is, I can write as either omega square R or V square by R, anything, or V omega. Okay, no problem. So I want what is the velocity here? If you want the tangential acceleration of A, it is VA square by R. So about this point is rotating. So therefore OA. So VA square by R. VA is already we have calculated 1.4 square and the radius OA is 0.7. So let me calculate this value. 1.4 square divided by 0.7 and this is 2.8 meter per second square. Once the tangential and normal acceleration are known and they are perpendicular, so if you want the acceleration, it will be under root of an square plus at square. Bilkul sahi hai, sirs. So therefore, it is 2.8 square plus 3.5 square and under root of this is, एक बार check करते हैं sir, 2.8 square plus this is equal to 4.48, sirs. So this square plus this square under root of this square plus this square, and I am getting the answer as 4.48 meter per second square. This approach can be used directly when he is asking a numerical value. Matlab just this is a scalar approach. Suppose he asks you simply what is the velocity and acceleration. This is absolutely fine. Suppose he asks the same question in vector form. For example, he may be asking you what is the velocity of point A. Options may be given I cap plus something j cap, something I cap plus something j cap, or even if the acceleration is asked I cap plus j cap, then you should be in a position to know everything. Let me do that also. This is, so we got the velocity as 1.4 and the acceleration as 4.48. ठीक है sirs. Let's see the vector approach. Now, okay, ठीक है sirs. एक काम करते हैं, ठीक है sirs. Now, fine. This is our point O. About this point, it is rotating. This angle is given to us as 15 degree. Now, the same question, if vector form, in vector form, it is asked, let this point be already given as A. Okay, sir. Now, about this point, it is rotating. It means he is asking the acceleration, absolute value of velocity, absolute value of acceleration. It means with respect to this, we have to calculate. बहुत simple है sir. चलो. This length is given as 0.5 and this length is given as 0.3, and already we have calculated, my dear students, already we have calculated this length, and this length is 0.7. All are in meter. Okay. Now, with respect to this, let us find out where is he asking us to calculate acceleration. Point A. So with respect to this, as it is rotating, this is the absolute point. इसके respect से ये घूम रहा है. So with respect to this, let us find position vector of A. चलो ठीक है sirs. Let's do that. Now let us try to find out the position vector of A. ठीक है sirs. Let this be some point B. Okay. So if you observe clearly, with O, this is my axis. This is my positive x-axis, this is positive axis. With respect to O, the point A is to the right, means x is plus. With respect to O, point A is below, so therefore it is minus. So let us write the position vector. But before I write the position vector, somehow, देखो ये length तो पता है, this is 0.7. So somehow I find out this angle. If I can find this angle, the total angle is known. So total angle का ये opposite sign होगा और ये adjacent cos होगा. ठीक है sir. Let's do that. No problem at all. ठीक है sir. Okay. How do I find this angle? Very simple, sir. Again, O, let us say this is D. ODA. Let me apply cos rule. Let this angle be some alpha. So can I write this square? 0.3 square is equal to 0.5 square plus 0.7 square minus 2 into 0.5 into 0.7 into cos alpha. Yes, sir. So 0.3 square is equal to, I am using applying cos rule for this triangle ODA. So 0.3 square is equal to 0.5 square plus 0.7 square minus 2 into 0.5 into 0.7 into cos alpha. Simple rule. So, कितना आ रहा है sir? 0.3 square is 0.5. Okay. This alpha will be equal to, if I calculate 21.786 degree, this alpha is 21.786, this angle is known. Now, can I find this total angle? this total angle is 15 plus alpha. This is 15, this is alpha. 15 plus alpha is total angle. So add karo 15, so it will be 36.786. This is 36.786. Excellent, sirs. Now, देखो sirs. So what to do, my dear students? Now this is known. So this triangle, let us take this OBA. I repeat, OBA. This is O, this is B, this is A. And OA length is already known, 0.7. Excellent, sirs. This is the point. This angle is, the total angle is 36.786. And if I calculate this 0.7 into sine 36, तो ये आएगा BA. If you want OB, it will be 0.7 into cos 36 point, ये adjacent है. So I can calculate OB and BA. So if I do that, I will get my direct calculate कर रहा हूँ sir. This is opposite. 0.7 sine 36 is 0.4192. And this OB, if you want OB, it is 0.7 sine, cos 36.7. This will be 0.5606. Now, with O, I can find the position of A. The position of A is, what is the position of A? Dekho sirs, with O, it is right. It is right. So X is positive. That is 0.4192 I cap. And observe carefully, with respect to O, Y is downward. Upward is positive, downward. With respect to O, A क्या है? नीचे है. How much is that? So therefore it is minus 0.5606 J cap. The position vector is known. No problem at all. Now, it is rotating in XY plane. When I say XY plane, the rotation is about Z axis. देखो, what is this alpha? देखो, omega is, it is in the clockwise direction. Omega is in the clockwise or anti-clockwise? एक बार check करते हैं sir. Omega anti-clockwise. Yes. तो anti-clockwise मतलब क्या होगा? So if it is anti-clockwise, it is outwards. So plus J, plus K. So therefore, omega will be equal to 2K cap. Very good, sir. Why positive? Omega is 2 because it is rotating in XY plane. Matlab about Z axis. But it is about positive Z axis. Anti-clockwise are positive, clockwise is negative. And alpha is, it is clockwise. Alpha is ulta. That in this problem it is given as clockwise. Ek baar dekhna. Alpha is given as clockwise. So therefore it is minus. Very good, sirs. All these vectors are known. Then how to find out velocity? You know very well. V is equal to, if you want, it is the position of A. If you want the velocity of A, it will be omega cross position of A. Excellent, sirs. Omega cross position of A. So therefore, IJK, what is omega? There is no I, there is no J, and K is plus. एक बार check करते हैं sir. No I, no J, K plus. And what about RA? 0.4192 I. 0.4192 I. And J is minus 0.5606. Minus 0.5606. There is no K, 0. There is no K. So I can easily find out I into this, minus J into this, minus J into this, minus this, plus K into this minus this. And if I find, I'll get the velocity vector A. What is that velocity vector? And that vector will be, my dear students, and that vector will be 1.1212 I cap plus 0.8384 J cap. Very good, sirs. Absolutely fine. Absolutely fine. So let us find out the magnitude. It will be under root of 1.1212 square plus 0.8384 square. If you are calculating, you will get the value and you are getting the same answer as 1.4 meter per second, which we got earlier. Now, let's find out acceleration. So, how do I find acceleration? Idhar dekho, sirs. V is equal to omega cross R. ठीक है, sirs. V is equal to omega cross R. Differentiate this velocity. So dV by dt Please note down that it is a vector and I am operating differentiation. So here calculus and vectors both are going hand in hand. They never interfere. Apna kaam apna, vector will do its own work and calculus will do its own work independently. So therefore, now differentiate karo. D omega, don't change the position of this, by dt into r cross, it is something like uv principle plus, एक बार इसको डिफरेंशिएट करो, इसको वैसे ही रखो, फिर बाद में इसको ऐसे ही रखना, कीप इट लाइक दिस ओनली. नाउ यू डिफरेंशिएट दिस dr cap by dt. Excellent, sirs. Now, so what is dv by dt? It is the total acceleration. So what is this, sir? Rate of change of omega is alpha and r cap, ठीक है सर, प्लस ओमेगा cross, what is rate of change of displacement, because change in position is displacement, per unit time is velocity, but I want the acceleration of a, so therefore position of a and velocity of a, absolutely. But don't write alpha of a, omega of a. Alpha and omega, the rotational properties are for the complete body, they are not for a point, because if the angular velocity at a particular point is 10 radian per second, for the complete body it will be same, because we are dealing with rigid bodies. So my dear students, already you know position of a, तो क्या करेंगे, I j k, alpha is, already we know alpha as it is clockwise, तो -5 दिया है sir. And RA, just now we have calculated RA. What is RA, sir? 0.4192, and this is minus 0.5606, and this is 0. इसका क्रॉस प्रोडक्ट करो, प्लस ओमेगा I j k, omega is already known 002, and VA, just now we have calculated velocity. What is the velocity, sir? 1.1212 and 0.8384, and say if you are calculating this, you know how to calculate cross product. So therefore the total acceleration, please note down that it is the tangential acceleration and it is the normal acceleration. So therefore you get the total acceleration. If you are adding, you will get the answer as minus 4.4798 I cap plus 2.2424 j cap. So this is the acceleration vector, and if you want the acceleration, it will be under root of this square plus this square and under root of this square plus this square, and you will get the answer as again 4 point कितना रहा है सर, just now we have calculated ना, एक बार देखते हैं, 4.4798 square plus 2.2424 square. एक second. No. This is the total acceleration is, it is 0.1464, sir. It is, I'm getting this as point, ये दोनों add करो, this one. So when you add, you will get this as 4.4798 minus RR and 0.1464 J cap. Yes, and if you are calculating, you should get, देखो एक बार, 4.4798 plus 0.1464, this is 20.09, under root is 4.48. Yes sir, we got meter per second square, we got the same answer. एक बार देखो, 4.48, somewhere we calculated, yes, 4.48, we got the same answer. So therefore you should be ready with both approaches, because we don't know in options what is given. Chalo, let's go to the next question. देखो sir, see the question. First, let me explain what this question is exactly about. What this question is exactly about. एक बार देखो, देखते हैं सर. Actually, the power screw turns, 6 question है सर ये, and simple sir. But understanding the question is very important. The power screw turns at a speed which gives the threaded collar C. This is the collar C. देखो, this is the threaded collar, ये threaded collar है. So एक screw है सर, power screw है, this is the power screw, On power screw, this power screw is rotated, thereby this collar, this also has a screw, therefore thread, so therefore ये नीचे आ रहा है सर. Clearly he has given the collar is coming down. अब देखो सर, जब कॉलर नीचे आ रहा है विथ व्हाट वेलोसिटी इट इज कमिंग 0.25. कहां देखो सर, द पावर स्क्रू turns at a speed which gives the threaded collar C, this threaded collar C, a velocity of 0.25 vertically down. मतलब ये collar is moving down vertically. ठीक है सर. Now, so, and B is the point on the collar. देखो ये है collar is C. On this collar, एक सेकंड देखना, एक B है सर, this is collar C, this is B, and this is moving vertically down. मतलब यहाँ पे threads है सर. So therefore जब इसको घुमा रहे हैं, when you are rotating this screw, therefore the collar also has screws. So therefore the screw is moving down. मतलब ये collar is moving down. Very good sir. But there is a slotted lever. देखो एक बार यहाँ पे एक लीवर है सर, इसमें एक स्लॉट है सर, देयर इज अ स्लॉट, एंड देयरफॉर व्हाट इज हैपनिंग, द स्लॉटेड लीवर इज आल्सो टर्निंग अबाउट द फिक्स्ड पॉइंट O. ओके सर, प्लीज अंडरस्टैंड द क्वेश्चन प्रॉपरली. एक सेकंड, इसको निकाल देंगे. ओ फिगर गया सर, पता नहीं सर ये ऐसा क्यों हो रहा है सर. अंडू कैसे करते हैं सर? हाँ आ गया सर, बहुत बढ़िया. ओ माय गॉड. ठीक है सर, अब मैं बताता हूं व्हाट टू डू. प्लीज अंडरस्टैंड, वेरी सिंपल क्वेश्चन. डिटरमाइन द एंगुलर वेलोसिटी ऑफ द स्लॉटेड आर्म when this angle is 30. देखो सर, बहुत प्यारा सा क्वेश्चन है सर. लेट अस टेक दिस एज पावर स्क्रू. ठीक है, एंड यू नो ये घूम रहा है सर. देखो ये पावर स्क्रू इज रोटेटिंग. एक काम करते हैं सर, लेट दिस कॉलर C is collar. ठीक है, B is a point on the collar. अंडरस्टैंड केयरफुली, ये B जो है ना, कॉलर के ऊपर एक पॉइंट है, एंड एक काम करते हैं, लेट A be a point coincident, let A be a point, or let A be a point on, डोंट वरी सर, मैं नीटली एक्सप्लेन करूंगा सर, इसको बहुत नीटली एक्सप्लेन करूंगा सर. लेट ए बी अ पॉइंट कोइंसिडेंट ऑन, कहां गया रे वो, ए पॉइंट, लेट ए बी अ पॉइंट on the slotted lever coincident, मैं लिखता हूं सर, पहले लिख के आपको समझाता हूं. लेट ए बी अ पॉइंट ऑन स्लॉटेड लीवर कोइंसिडेंट विथ पॉइंट बी ऑन द कॉलर. सर कुछ भी समझ में नहीं आया? बहुत बढ़िया, आई विल एक्सप्लेन. लेट ए बी अ पॉइंट ऑन द स्लॉटेड लीवर. This is the slotted lever. A is a point on the slotted lever which is coincident with point B on the collar. Understand carefully. B is on the collar. A is on the slotted lever. They are coincident. It's something like this, my dear students. अब दोनों ऐसे है. तो let us say this is A on one, B on one. They are coincident. They are coincident. So where is point A? A is on the slotted lever. A is on the slotted lever and B is on the collar. So what will be the velocity of B? Clearly bola, B is on the collar. Collar has a velocity vertically down. Vertically down. बहुत बढ़िया सर, great. ठीक है, please understand my dear students, simple analysis. So this is the velocity. अरे ठीक है सर, तो मैं क्या करूं, एक काम करता हूं सर, नीटली आई ड्रॉ अ फिगर. नीटली आई ड्रॉ अ फिगर, डोंट वरी, तो अच्छा समझ में आएगा सर आपको. दिस इज अ वेरी गुड क्वेश्चन. डोंट वरी सर, इसको थोड़ा नीटली एक्सप्लेन करेंगे. डोंट वरी, डोंट वरी, आई विल टेक व्हाइट कलर ओनली, व्हाइट ही अच्छा रहेगा. And it is like this. Okay, sir. No. Okay, no problem at all. ओहो, ओ ये ऐसा है क्या? इसको इरेज कैसे करते हैं सर? चलो, पता नहीं यार, मुझे नहीं आ रहा सर. कोई बात नहीं, आई ड्रॉ फ्री हैंड. विथ फ्री हैंड ड्रॉ करता हूँ सर. विथ फ्री हैंड आई ड्रॉ, नो प्रॉब्लम. This is the screw and this is the collar. ठीक है सर. There is a slotted lever. ठीक है. देखो सर. वो क्या रहा है सर? Please understand. If you observe, there are three velocities. One is absolute velocity of point A, absolute velocity of point B, and the relative velocity. कुल्ली देखो सर. इसके रेस्पेक्ट से, if I talk with respect to O, with respect to O is fixed point. Whenever you are calculating with respect to a fixed point, it is absolute velocity. So what will be the absolute velocity of point A? Where is point A? A is on the slotted lever. मुझे बताइए, O के रेस्पेक्ट से, O के रेस्पेक्ट से ये slotted lever क्या करेगा सर? It rotates, it rotates, it rotates. Very good sir. वेरी सिंपल. जब ये नीचे आ रहा है, when it comes down, you see this. देखो, when this is coming down, you see this occupying some this position. जब ये collar नीचे आ रहा है, when this is coming down, after some time you see this slotted lever moving like this, means it is rotating in anti-clockwise rotation direction about this point. ठीक है सर. तो क्या करूंगा सर? प्लीज नोट डाउन दैट A is on the slotted lever, SL slotted lever. B is on the collar. Both are coincident points. अब देखो सर, now let me erase this. अरे यार, एक सेकंड. वेरी सिंपल क्वेश्चन है सर. ये इतना सिंपल क्वेश्चन है, आपको समझाने के लिए आई एम टेकिंग टाइम. A is on the slotted lever, B is on the collar. देखो एक बार, what is the motion of the collar sir? एक सेकंड देखो. motion of the collar, it is moving downwards. so therefore color change करेंगे ताकि मजा आएगा. लाल ले लेंगे. ठीक है सर, थोड़ा. ठीक है. this is the velocity of किसका? point B. this is the velocity of point B. B is on the collar, तो collar नीचे आ रहा है, इसको लिखेगा मैं VB. ठीक है. एंड विथ रेस्पेक्ट टू O, देखो जब ये नीचे आ रहा है, इट मूव्स लाइक दिस. सो विथ रेस्पेक्ट टू O के रेस्पेक्ट से A का वेलोसिटी कैसा होगा? इट विल बी विथ रेस्पेक्ट टू O, ये घूम रहा है ऐसा, सो इट विल बी परपेंडिकुलर टू दिस. ऐसा आएगा सर. इस लिंक को इट विल बी परपेंडिकुलर टू दिस लिंक. ठीक है सर. अरे यार, अरे हो क्या रहा है रे? बहुत मुश्किल है सर. कोई बात नहीं, हम तो छोड़ेंगे नहीं इसको. देखो, this is the velocity of point B. B is on the collar. देखो, collar. So I read this as VB. What will be the velocity of point A? A is on the slotted lever. तो O के रेस्पेक्ट से A ऐसा perpendicular इसको, when it is rotating velocity will be perpendicular, so therefore now I write this, कहां गया रे, ये वाला ले लेंगे, तो इस लिंक को परपेंडिकुलर होगा सर, बहुत बढ़िया, बिकॉज इट इज रोटेटिंग, जब ये नीचे आ रहा है, जब ये नीचे आएगा, देखो when it comes down ये ऐसा घूमेगा, इसलिए आई एम राइटिंग लाइक दिस. What is this, sir? It is velocity of A. Why it is absolute? Because with respect to O, with respect to this fixed क्या बोलते हैं power screw, the collar is moving. So therefore ये absolute velocity of B ये है. लेकिन अब सुनो ध्यान से, it's not complete, sirs. मुझे बताइए B के रेस्पेक्ट से C क्या करेगा सर? कुछ नहीं करने का. B means on the collar, on the collar. B means on the collar. फिक्स करो और कॉलर को दिस स्लॉटेड लीवर को मूव करो. सो देयरफॉर विथ रेस्पेक्ट टू बी, सी दिस कैन स्लाइड ओनली, मतलब रिलेटिव वेलोसिटी बिटवीन ए एंड बी विल बी अलोंग दिस, अलोंग दिस, अलोंग दिस. सो देयरफॉर एक लाइन ऐसे ड्रॉ करना सर, बिकॉज एक सेकंड दोबारा बता रहा हूं सर, लेट मी रिपीट सर, लेट मी रिपीट. विथ रेस्पेक्ट टू क्या बोलते हैं दिस बी पॉइंट, ए क्या करेगा सर? ये स्लाइड करेगा. सो हाउ, एक अगर रिलेटिव मोशन चाहिए तो एक को फिक्स करके दूसरे को मूव करके देखना. इफ यू वांट द रिलेटिव वेलोसिटी ऑफ दिस क्या बोलते हैं पॉइंट ए विथ रिस्पेक्ट टू, घुमा के देखना, रोटेट्स. विथ रिस्पेक्ट टू दिस फिक्स्ड वन द कॉलर स्लाइड्स एब्सोल्यूट. सो अगर ए और बी में, ए दे आर कोइंसिडेंट पॉइंट्स, ए को फिक्स करो या फिर बी को फिक्स करो, और इफ यू सी पॉइंट बी, बी के रेस्पेक्ट से ए क्या कर रहा है सर? इट कैन स्लाइड, इट कैन स्लाइड पैरेलल टू दिस, पैरेलल टू दिस. सो इसको पैरेलल ड्रॉ करना सर, ड्रॉ पैरेलल, इसको, इसको पैरेलल. ठीक है सर, वेरी गुड सर. अब देखो दिस इज पैरेलल, दिस इज, नाउ आई राइट, देखो डायरेक्शंस आर वेरी इंपॉर्टेंट. इधर देखो ये क्या होगा सर? ये किसका वेलोसिटी है सर? कहां से कहां जा रहा है? बी से ए जा रहा है, तो दिस इज द वेलोसिटी ऑफ ए, किसके रेस्पेक्ट से? बी सर. आप बी से ए के तरफ जा रहे हैं, इट मींस इट इज द वेलोसिटी ऑफ ए विथ रेस्पेक्ट टू बी. दिस कंप्लीट्स द ट्रायंगल. ऑलरेडी वीबी इज गिवन एज 0.25. एक्सलेंट सर, वीबी इज टू 0.25. देखो ये लाइन पैरेलल है और इसको ये परपेंडिकुलर है, तो दिस विल बी 90 डिग्री. आई रिपीट सर, टू दिस लाइन दिस इज परपेंडिकुलर, ओके, ये इट इज पैरेलल, सो देयरफॉर ये और ये परपेंडिकुलर 90 डिग्री. वंडरफुल सर. मेरे प्यारे दोस्तों इधर देखना, अब देखो ये 90 है सर, ये 90, तो ये कितना होगा सर? 60 होगा. जब ये 60 होगा, इस लाइन को ये परपेंडिकुलर है, सो ये 30 है, दिस द ट्रायंगल. सो इफ दिस इज 60, ये इस लाइन को ये परपेंडिकुलर है, सो टोटल विल बी 90, सो दिस विल बी 30. माय ट्रायंगल इज कंप्लीट नाउ. देखो इट इज वी ए, ठीक है सर जी, इट इज वी बी, ठीक है सर जी, एंड ये परपेंडिकुलर है. देखो सर ये and what is this angle? It is 30. Already you know VB as the velocity is of this collar is 0.25. पूछा क्या है सर? क्या कर रहे हैं हम लोग? Very good sir. What I am trying to do is I will try to find out the velocity of A. Where is A? It is on the slotted lever. If I find the velocity of A which is on the slotted lever, he is asking the angular velocity of this. अगर A point which is on the slotted lever, देखो ये slotted lever है, A point यहां पे है, and if I know the velocity of A, I can easily find out omega of this. How? V is equal to R omega. So इस point पे ये घूम रहा है, तो I will calculate this length, and if this length is known, if there is velocity is known, V is equal to VA is equal to R omega, and you will get the omega as V by R. चलो पहले आप VA कैलकुलेट करो, बहुत सिंपल है सर. एक बार देखना सर, ये अपोजिट है तो ये साइन होगा, ये हाइपोटेन्यूस. क्यों हाइपोटेन्यूस है? बिकॉज इट इज 90. ऑलरेडी यू नो 90. सो ये दिस इज, ये अपोजिट है, ये एडजेसेंट है, तो कैन आई राइट VA इज इक्वल टू VB cos 30. I repeat, sirs. VA is VB cos 30. Excellent. So I will get the value of VA. What is VB? It is 0.25 into cos 30, sirs. तो बताइए कितना आ रहा है सर? 0.25 into cos 30. Cos 30 into 0.25. You get the value as VA is equal to 0.2165 meter per second. What is the meaning of VA? It is the velocity of point A which is coincident with point B. Velocity of point A. Where is point A? It is on the slotted lever. तो आ गया सर. अब मुझे बताओ सर, how can I calculate this length? How can I calculate this length? Already you know this length is 4. एक बार देखना सर. Let us take this as A or B or C. C है. A or B or C जो भी है. And this is चलो collar C कोई बात नहीं. And O है. And this length is given. What is this length given sir? ये length कितना है? 450. This angle is 30. तो can I find out this length sir? क्या मैं इस length को find? बिल्कुल sir. Cos 30 is equal to cos theta is 450 by, let us take this as R. So you get R as 450 by cos 30. 450 divided by cos 30. So this value will be 519. So ये length आएगा 519.6. Very good sir. That is in mm. So if you want in meter, 0.5196. So what will be the angular velocity of this slotted link? अगर angular velocity चाहिए, V is equal to VA is R omega. So what is VA sir? Already VA is done. 0.2165 is equal to R अभी calculate किए 0.5196 into omega of slotted. So this will be कितना आ रहा है सर? 0.2165 divided by 0.5196, and this is coming out to be omega of slotted link is equal to 0.4166 radian per second. But it is in which direction? When this is moving down, जब ये नीचे कर रहा है तो ये ऐसा हो रहा है. It is in the counterclockwise direction, CCW. It's a very good question, sir. Let me check the answer. कहाँ गया रे? 0.416 is correct, counterclockwise. Hope you understood. A good question again. ठीक है सर. देखो, whenever you want the relative velocity, एक लिंक को फिक्स करके दूसरे को मूव करना. That will give me the relative velocity direction. ठीक है? चलो. Now let's go to the next question. Take this question. The right angle link, observe carefully. This is a right angle link. Yes. A right angle link AB has a clockwise angular velocity. देखो सर, clockwise angular velocity of 2 radian per second. When in the position shown, determine the velocity of B with respect to A. ठीक है सर. Determine the velocity of B with respect to A at this instant. And clearly given this is positive x-axis, this is positive y-axis. Okay, no problem at all. How do we do this, sir? He is asking velocity of B with respect to A. ठीक है सर. Velocity of B with respect to A. एक second. कहाँ गया रे? Okay. How do we do this? Velocity of B with respect to A. You know very well, whenever there is a relative velocity, it is because of rotation. चलो मैं आपको बताता हूं सर. Simple logic बताता हूं. इधर देखो सर. Suppose there is a rigid body. We are dealing with rigid bodies only. There is point A, there is point B. Let it undergo pure translation. When it undergoes pure translation, what is the relative velocity of B with respect to A? Both are moving with same velocity. There is no relative velocity. Under pure translation, there is no relative velocity. अब देखो, Now suppose the link is rotating. Let this be point A and let this be point B. Okay, now let the link rotate at omega. Okay, so here the velocity will be this length RA into omega. Here the velocity is RB into omega. Okay, now I want this is the absolute velocity of A. It is with respect to this point. It is the absolute velocity of B. It is with respect to this point. Now I want the relative velocity of B with respect to A. If you want the relative velocity of B with respect to A के respect से, so what is the difference or what is the difference? So it will be RB omega minus RA omega or RB minus RA into omega. This is the relative velocity. This is the relative velocity. Relative velocity is nothing but it is the distance between the points. देखो RB RA के बीच का distance into omega, R omega will give me the relative velocity. Yes, yes. अब देखो, already omega is known. I want the relative velocity of B with respect to A. क्या करेंगे सर? पहले आप BA का distance calculate करो सर. Yes. Let me calculate the distance. So this is 300. This is 300 and this is 125 and it is 90 degree. So under root of this square plus this square will be equal to this square. So let me calculate AB distance. RAB. So that will be equal to under root of 300 square plus 125 square. So this will be equal to, I think we are getting this as, कितना आ रहा है sir? Let me calculate. 325 mm. All are in mm. 325 mm. Or this can also be written as 0.325 meter. Excellent, sir. Now, how to find out the relative velocity of B with respect to A? The distance between them into omega. That's it, sir. So, therefore, R omega, that is 0.325. अभी तो बताया sir. Just now I told you. इधर देखो. So, if you want the relative velocity, distance between them into omega. Okay. Distance between them is 0.325 meter. And omega is, how much is the omega? 2 radian per second. So therefore, this is so many radian per second. So therefore, it is 0.325 into this is 0.65 na meter per second is the relative velocity. एक बार check करते हैं sir. 0.65 is correct. Now, for example, the same question. If the same question is asked in vector form, how will you do? The same question is asked in vector form, how to attack. The answer is 0.65, sir. Okay, it's over. Now let me do this question. If he is asking in vector form, तो कैसे करेंगे sir? इधर देखो sir. The same thing. देखो. What I do is, he is asking velocity of B with respect to A. तो क्या करो? A के respect से find the position of B, because he is asking the velocity of B with respect to A. A के respect से you find the position of B. Yes. देखो, I think I can find this angle. देखो एक बार. See, actually क्या दिया है ना? ये angle I think we can calculate. How can we calculate? Very simple, sir. So this is opposite ना? ये 125 है. तो ये 325 है. I can easily calculate. Okay. So let me calculate. So, or we can write tan alpha is equal to, if this is alpha, so this length is 125, this is 300. Tan alpha is opposite by adjacent. So therefore, 125 divided by 300, I want tan. So it is 22.6. Correct, sir. So ये total angle आएगा, sir. Let me write clearly. This is point A. ठीक है, sir. This is point B. And if you observe, कौन सा total angle बोल रहा हूं sir? Vertical के respect से, ये vertical के respect से देखो, ये वाला एंगल बता रहा हूं सर, ए बी का एंगल, I know this total angle, this total angle, this total angle, this total angle. So this is 30 and this is 22. ये total angle R का with respect to vertical. So this AB, this is AB with respect to vertical. How much is this, sir? 30 plus this is 52.6. Okay, sir. Now I want the position of, look at carefully. आराम से, टेंशन नहीं लेने का. हाँ जी सर. I want the position of P with respect to A. This is my coordinate system. ठीक है सर. This angle is 52.6. तो I will get with A, ये X distance आएगा सर. How much is this? It will be, ये length is known to me. What is this length, sir? It is 0.325. Of course 325 है, तो it is, this is 325 है, 0.325 opposite. So it will be 0.325 sine of 52.6. Very good, sir. How about this? ये cos होगा 0.325 cos 52.6. 52.6. तो ये with respect to A, what are the coordinates? X is right means plus, ये plus आएगा. Y is down तो minus आएगा. तो this values are known. So I will get the position of B with respect to A. तो कितना आ रहा है सर? Position of B with respect to A. So if I do that, I will get, एक सेकंड, तो ये आ रहा है, ये लेंथ आ रहा है सर. दिस लेंथ इज 0.325 sin 52.6. तो ये आ रहा है 0.25825, 0.25825. और ये आ रहा है सर, ये आ रहा है 0.1973. सो वेक्टर क्या होगा सर? x का विथ रिस्पेक्ट टू दिस, x इज प्लस, y इज माइनस. तो द पोजीशन ऑफ b विथ रिस्पेक्ट टू a इज 0.25825 i cap minus 0.1973 j cap. Excellent, sir. But what is he asking? Velocity पूछा है, r omega. So velocity of b with respect to a is equal to omega cross r. Excellent, sir. V is r omega, vector में omega cross r. What is omega given? Already omega is given as, देखो omega is in the clock, clearly it is given, sir, clearly omega दे रखा है clockwise. So therefore omega vector can be written as minus 2k. Why minus? Because it is clockwise. So I know omega vector, I know r vector, so just calculate the cross product. So velocity of b with respect to a is equal to ijk, omega is 0 0 minus 2. एक बार चेक करते हैं, 0 0 minus 2 and 0.25825, 0.25825. Okay, and position minus 0.1973, minus 0.1973. There is no k. देखो I have written. So if you take the cross product, अगर आप इसका cross product लेते हैं, तो you will get the velocity as, एक बार देखता हूं सर, 0 0 minus 2, 0.255 point, yes. So if I take the cross product, you are getting velocity of b with respect to a as minus 0.3946 i cap minus 0.5165 j cap. तो आपको तो आंसर सेम आना चाहिए सर. कितना आना चाहिए सर? हम तो स्केलर अप्रोच से किए थे. विथ फ्रॉम स्केलर अप्रोच वी गॉट द आंसर एज, कितना आया था सर? मिटा दिया मैं, पागल हूं मैं. सो इट इज, आई गॉट 0.325 इंटू 2, 0.65. यहां पे भी उतना ही आना चाहिए सर. चेक करते हैं सर, कहां गए रे वो? ये तो अंडर रूट ऑफ दिस स्क्वायर प्लस दिस स्क्वायर, अंडर रूट ऑफ दिस स्क्वायर प्लस दिस स्क्वायर, चेक करो. minus 0.3946 square minus 0.516 square. Let me check. 0.3946 square, 0.5165 square, 0.6499, which is nothing but 0.65. So why I am giving all these approaches, you should understand clearly. Hope this is clear. Wonderful, sir. Wonderful. Now let's take the next question. दिस इज अ वेरी गुड क्वेश्चन. दिख रहा है सर आपको? मैं ड्रॉ करूंगा सर, डोंट वरी, लेट मी ड्रॉ. At the instant represented, the velocity of point A of 1.2 meter bar, there is 1.2 meter length bar. Is at this instant A has a velocity in the positive x direction, and that is given as 3 meter per second. ठीक है सर. Determine the speed of point B and the angular velocity of this bar. The diameter of the small end wheels, these are small wheels, is neglected. Chalo sirs, let me redraw the figure so that you can understand in a better way. This is a very good question, sir. I request everyone to read the question. So actually, this is the quarter of a circle. Look at this, diameter is 0.5, this diameter is 0.5, and this angle is given as 60. So it is the quarter of the circle, and this is the straight path. So this end of this bar is moving in a quarter of the circle, and when the angle is 60 degree, he is asking the velocity of this point B, which is moving along this, and not only the velocity but the angular velocity of this complete link. So one information is given, some information is given. This length is 1.2 meter, and the velocity of this a point is 3 meter per second towards right. Chalo, let's do this question. देखो सर, पहले मैं neatly figure draw करूंगा सर, so that you can understand it a bit better. कहाँ कौन सा ले लूं सर? ठीक है, कोशिश करूंगा सर, like because I am not used to this smart board, I'll try my level best. आएगा नहीं आएगा, एक सेकंड, इसमें इरेजर कहाँ रहता है रे? देखेंगे एक बार. आई डोंट हैव आइडिया क्या करते हैं, एक बार देखता हूँ. कलर बोर्ड आ रहा है इसमें, और क्या है एक बार चेक करता हूँ सर. हाउ कैन आई इरेज? नहीं आ रहा है. चलो कोई बात नहीं, नो प्रॉब्लम, नो प्रॉब्लम सर. विल ट्राई टू अंडरस्टैंड प्रॉपरली. डोंट वरी, डोंट वरी, कोशिश करेंगे. डोंट वरी सर. नाउ एक बार ओरिजिनल क्वेश्चन देखो. ओके, नो प्रॉब्लम. वर्टिकल हॉरिजॉन्टल, यहाँ पे 60 30 लाइन ड्रॉ करता हूँ सर. ठीक है, yes. This angle is given as 60 degree. Okay, प्लीज अंडरस्टैंड, along this path, इसको थोड़ा कलर चेंज करेंगे ताकि आपको समझ में कुछ आ जाए. is actually a wonderful question, sir. Mhm, mhm, mhm. Right. Please. Uh, it is sliding like this, and this end is moving like this. ठीक है, sir. And A, B, okay. This is A, and this is B. Okay, fine. This length is given as, this radius is given as 0.5 meter. अगर ये 0.5 है तो ये भी तो रेडियस है, सो ये वर्टिकल लेंथ इज आल्सो 0.5. ठीक है सर. दिस इज बेसिकली इट टेस्ट ज्योमेट्री सर. आपका ज्योमेट्री कैसा है ये चेक करेगा सर. दिस विल चेक योर ज्योमेट्री. सो दिस इज पॉइंट बी. ओके फाइन. नो एक्चुअली दिस लिंक इज स्लाइडिंग. कहां गया रे वो? एक सेकंड सर, इसको मोटा ले लेंगे. ये वाला लिंक है सर. ओके. This link is sliding, and this is point B, and this is point A. ठीक है. And this velocity is given, and this is given as कितना दिया सर? 3 meter per second. Okay. On this path, it is sliding and it is moving like this. ठीक है सर. Must question है सर ये. This is a very good question. He is asking at the instant when this angle is 60 degree, what is the velocity of this point B? Agreed. How do we do this? एक काम करते हैं सर. तो I'll do one thing. How will be the velocity? मेरे प्यारे दोस्तों, velocity कैसे रहेगा सर? To this it will be perpendicular. इसको perpendicular रहेगा. Yes, 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 absolutely, undoubtedly. तो कलर क्या ले लेंगे सर? यही ले लेंगे. आप क्या करते हैं? So इसको देखो, तो इस पाथ को, इस पाथ को, इस पाथ को, it will be perpendicular. टेंजेंशियल टू दिस. मतलब फिगर उतना सही नहीं दिया. तो देखो कैसा होगा सर. इट इज मूविंग लाइक दिस, तो इस पाथ को टेंजेंशियल, इस सर्कुलर को, बिकॉज इट विल मूव अलोंग द सर्कल, तो इट विल बी टेंजेंशियल टू दिस. ये टेंजेंट टू दिस, तो ये एंगल होगा आपका. देखो आई विल राइट दिस एज वेलोसिटी ऑफ बी. सो जब ये ऐसा स्लाइड हो रहा है, दिस इज द वेलोसिटी ऑफ बी. ठीक है सर. ओके. सो ये सर्कल है. सर्कल ये देखो, ये सर्कल के टेंजेंशियल ऐसा मूव होते जाएगा. ठीक है सर. नाउ द थिंग इज वी नीड टू फाइंड एंगल्स. बहुत इंपॉर्टेंट है एंगल्स फाइंड आउट करना सर. एक बार देखो. ठीक है सर. तो दिस इज 90, सो डेफिनेटली दिस विल बी 30 डिग्री. दिख रहा है सर आपको? यस, बहुत अच्छा दिख रहा है. दिस इज 30 डिग्री. नाउ if this angle is theta, what will be this angle sir? This is horizontal, this is also horizontal, same line. So I am asking you sir, what will be this? If this is theta, this will also be theta na. So therefore अगर ये theta है तो ये भी theta ही होगा सर. बहुत बढ़िया सर जी. ठीक है. नाउ द क्वेश्चन इज, मैं क्या करूं सर? एक काम करते हैं सर. द प्रॉब्लम हियर इज हाउ टू फाइंड आउट दिस एंगल. इफ दिस एंगल इज फाउंड, द प्रॉब्लम इज सॉल्व. मैं सोच रहा हूं सर, इस एंगल को कैसे फाइंड आउट करें. सोचो सोचो सोचो. तो एक सेकेंड. थिंक थिंक थिंक. यू थिंक सर. एक बार सोचो. हाउ टू फाइंड आउट दिस एंगल. एक बार मैं एक लाइन ड्रॉ कर रहा हूं सर. ठीक है. माय डियर स्टूडेंट्स, ये लेंथ दे रखा है सर. दिस लेंथ इज 1.2 मीटर सर. दिस लेंथ इज, दिस AB लेंथ इज 1.2 मीटर. So somehow if I find this length, this is known. So sin theta will be equal to this by this. I repeat, sin theta will be equal to this. इसको क्या ले लेंगे सर? AB हो गया ना, चलो इसको C ले लेंगे. तो sin theta is BC by AB. But how to find this length? बोलो सर, ये लेंथ कैसे करें? मुझे पता है सर. This is the circle. तो this will be 0.5 मीटर. एग्जैक्टली ये 0.5 सेंटर से ये 0.5 मीटर है सर. So now, can I find out this length? If this is known, so what I do is from the total length of 0.5, if I remove this length, I get this length. From this length, I can calculate angle theta. If that is known, the problem will be very simple. देखो sir, तो opposite, this is 0.5 because it is radius. ये तो radius है sir, 0.5. तो ये क्या होगा sir? सुनो carefully. So can I write this length as, ये opposite है, अरे यार 60 ये है, इससे कंफ्यूज मत होना सर, इसको थोड़ी देर के लिए निकालना, मुझे पता है सर ये 60 है, आई नो दिस एंगल इज 60, ठीक है सर. तो कैन आई राइट दिस लेंथ एज अपोजिट इज साइन 0.5 sin 30, sin 30 is half, 0.5 sin 30, this is 0.25, sin 30 is half, 0.25. This total length is 0.5, this length is 0.25, so this will be 0.25. BC length will be equal to 0.25. Once this length is known, sin theta will be equal to, sin theta is opposite, that is 0.25 by the hypotenuse. This length is 1.2. Let me calculate, sirs. So 0.25 divided by 1.2 and I want sin. तो 12.02 आ रहा है सर. वेरी गुड सर. इफ दैट इज नोन, अब मैं थोड़ा नीट करूंगा सर इसको, तो ये पता है सर, तो मुझे बताइए, इफ दैट इज नोन, प्लीज लिसन, कैन यू टेल मी दिस एंगल? इट्स ओनली ज्योमेट्री सर, ज्योमेट्री. ये 12.02 है सर, बिकॉज दिस थीटा. तो ये टोटल एंगल इज नोन टू मी 30 प्लस 12.02. 30, this is 12.02, it is 42.02. if that is 42.02, आप जानते हैं ये लाइन और ये वेलोसिटी तो परपेंडिकुलर होगा, क्योंकि ये सर्कल के लिए नॉर्मल है, ये टेंजेंट है, तो ये 90 डिग्री है. दिस टोटल इज 90 डिग्री, ये 90 डिग्री है सर, ये टोटल इज 90 डिग्री. दिस इज 90 डिग्री एंड दिस एंगल इज 42.02. तो कैन आई फाइंड आउट दिस एंगल? लेट मी रिपीट सर, ये 90 डिग्री है सर, दिस 90, जिस वेलोसिटी से ये टेंजेंशियली आ रहा है इसको, ये नॉर्मल है, तो ये टोटल 90 है. बट दिस इज 12.02 and this is 30. This total is 42.02 and this total is 90. ये total 90 है, ये 42.02, उससे ये निकालना. You remove from 90. From 90 if I remove 42.02, I get this angle, I get this angle, I get this angle. So what is that angle sir? It is कितना आ रहा है सर? 90 minus 42.02, it is 47.98. प्रॉब्लम हो गया सर, प्रॉब्लम हो गया सर. कैसे हो गया सर? अब मैं बताता हूं. लेट अस टेक दिस. सो लेट मी होप यू अंडरस्टूड दिस. हमने क्या किया सर? बहुत सिंपल है. ये लाइन है, ये लाइन है, ये वेलोसिटी VA है सर, VB, ये VB है सर, ये लाइन B, ठीक है, दिस इज 90. ओके, नाउ यू नो ये लाइन है सर, ये वाला लाइन है सर, ये वाला लाइन. प्लीज अंडरस्टैंड, this is 12.02 and this is 30 degree, so this total is 42.02 and this total is 90. ये 90 है सर, 90 में से 42.02 निकालना, it will be 47.98 ना, राइट. तो ये तो लिंक है सर, दिस इज द लिंक, दिस इज द लिंक, दिस इज द बार. तो ये बार वेलोसिटी इज 47.98 डिग्री पे एक्ट कर रहा है विथ रिस्पेक्ट टू दिस, ये 47. और ये ऑलरेडी नोन, ये कितना है सर? ये हॉरिजॉन्टल है. एंड अब मैं ड्रॉ करूंगा, बहुत सिंपली देखो सर, बहुत सिंपली देखो. नाउ अब सवाल आसान हो गया सर. दैट्स व्हाई आई सेड इट इज प्योरली ज्योमेट्री. That's why I said it is purely geometry. This angle is 47.98. 12.02. If this is 12.02, same straight line, same line, this will also be 12.02. Are yaar, same line, so 12.02. अब कैसे करें सर? बहुत सिंपल है. It is a rigid bar. For a rigid bar, will there be any relative velocity along the link? No. It will be VA cos alpha. अगर ये point A है, alpha is 12.02 and this is beta मान लो, this is point B. So many questions I have done in class. So what is the velocity? This is velocity B. What is the component of this velocity along the link? Opposite is ये sin होगा और ये cos होगा. So this will be the component of this velocity in this direction along the length of the link is, so it will be VB cos 47.98. Very good, sirs. Similarly, the component of this, ये opposite होगा, ये link के perpendicular, along the length चाहिए, तो along the link, along this will be opposite. This is sin, this is cos, so VA cos 12.02. So, you know it is a rigid link. For a rigid link, there will not be any relative velocity along the length of the link. So, equate these two. That is VB cos 47.98 is equal to VA cos 12.02. Excellent, sirs. So, already VA is given to us 3 meter per second. Already VA is 3 into cos 12.02. And if you want VB, so if you want VB, divide with this cos 47 point. It is a pure geometry, sir. These are all very good questions, sir. For understanding velocity acceleration properly, geometry is very important, sir. Divided by cos 47.98. And I am getting the velocity of B as 4.38 meter per second. Let me check the value, sir. Excellent, sir. 4.38 is correct. Now, the question is not over, sir. एक बार देखो. What is the velocity of point B? 4.38. And the angular velocity of the bar. How to find out the angular velocity of the bar? It is very important, sir. आप कैसे करेंगे, sir, angular velocity of the bar? ठीक है. I'll show you how to do this. Let me do this by VB is 4.38. Okay. Let me erase this. VB is 4.38. These are all very, very important questions, sirs. Okay. Now, you know, my dear students, I'll go by instantaneous center method. तो कैसे करेंगे सर? इधर इधर ही कर ले तो अच्छा आएगा. शायद इधर ही कुछ प्लान करेंगे सर. We'll try to do in this figure only. You'll understand properly. तो इसको थोड़ा हटा लेंगे. ये सब हटा लेंगे. Yes, we can do it here. Neatly करेंगे सर. Don't worry. Okay, sir. अब देखो. Now, the velocity of this point is कलर चेंज करता हूं सर. Okay. Now, the velocity of this is ये एंगल कितना था सर? 47.98. ठीक है सर. This is VB. Just now we have calculated 4.38, something like that. एक बार check करता हूँ sir. 4.38. Yes, yes, yes. What I do is, ध्यान से सुनो, ये एंगल इज ऑलरेडी गिवन, दिस इज 60 डिग्री. एक्सलेंट सर. इसी को एक्सटेंड देखो एक बार. द सेम, कितना सिंपल क्वेश्चन है सर, डोंट वरी एट ऑल. सो द सेम स्ट्रेट लाइन आई विल एक्सटेंड. ठीक है सर. देखो, इस वेलोसिटी को परपेंडिकुलर ड्रॉ किए और इस वेलोसिटी को आप परपेंडिकुलर ड्रॉ करना. मैं बताया था सर, व्हाट विल बी दैट पॉइंट. मींस सो व्हेनेवर इस वेलोसिटी को ये परपेंडिकुलर, इस वेलोसिटी को ये परपेंडिकुलर, so this will be the instantaneous center. It means as if this link is fixed about this point and it is rotating like this, as if it is rotating. एक बार rotation देखो कैसा दिख रहा है आपको. About this point it is rotating like this anti-clockwise. About this point ये ऐसा घूम रहा है. Suppose I calculate this length. अगर ये length आ गया तो V is equal to R omega. तो R omega. Already I have done so many questions on this. But how to find out? Let this length be R. How to find out this? बहुत simple है sir. And you know this angle. How much is this angle? 12.02. तो what will be this angle sir? ये total 90 है sir, total 90. So ये vertical, ये horizontal, total 90. 12.02. You remove from 90, you remove 12.02. So this is 77.98. Excellent sir. ये लाइन को ये परपेंडिकुलर है, तो व्हाट विल बी दिस एंगल सर? दिस टोटल इज 90. 90 में से 47.98 निकाल देना सर. 47.98. सो यू विल गेट 42.02. यू मे बी वंडरिंग सर व्हाई आर यू डूइंग ऑल दिस थिंग्स. बताता हूं सर, आई विल टेल यू, डोंट वरी. ठीक है सर. नाउ देखो, व्हाट इज दिस लेंथ? 1.2. Can I calculate this angle? Because it is a triangle. अगर ये triangle है, already ये तो 60 पता है सर मुझे already. If you want, you can also calculate this plus this should be 180. Yes, if you do, you will get, already you know, ये 180 दिया सर. 42.02 plus 77.98. Yes, 120 तो correct है सर. अब मुझे बताओ, can I calculate this length? Whenever three angles are known and one side is known, I can use sine rule. What is sine rule? Sine, देखो देखो, 1.2 by sine 60 is equal to R by 40. ये triangle sir, let us name this triangle A B I, instantaneous center. तो क्या होगा? A B I, one angle is 60, उसका opposite side is 1.2. One angle is 42.2, इसका opposite side R है. One angle is 77, उसका है. तो कैन आई कैलकुलेट दिस लेंथ? इधर यू कैन कैलकुलेट दिस लेंथ और दिस लेंथ. अगर ये लेंथ कैलकुलेट करेंगे तो VB इज इक्वल टू R ओमेगा, और इफ यू कैलकुलेट दिस लेंथ VA इज इक्वल टू R ओमेगा. यस, सो व्हाट विल बी दिस लेंथ सर? तो कैन आई राइट 1.2 बाई साइन 60, साइन रूल, 1.2 बाई साइन 60 इज इक्वल टू इसका अपोजिट R बाई साइन 42.02. बताओ सर कितना आ रहा है सर ये? सो साइन 42.02 into 1.2 divided by sin 60. I am getting this R as 0.927 meter. So if you want this, the angular velocity of this complete link, it is something like as if this link is, that is the concept of instantaneous center, as if this link is fixed about this point and rotating. What is the rotation? इस point पे ये anti clockwise होगा, तो ये link will be in the anti clockwise direction. तो VA is equal to R, this length is R, about this point VA is equal to ये perpendicular है R into omega. So omega will be, VA is 3 and R is 0.927 into omega. Let me calculate. कितना आ रहा है सर? 3.23 काउंटर क्लॉकवाइज. CCW इज काउंटर क्लॉकवाइज, ये काउंटर क्लॉकवाइज आ रहा है सर. मस्त क्वेश्चन है सर ये. वंडरफुल सर, वंडरफुल, बहुत बढ़िया. ठीक है सर, नेक्स्ट क्वेश्चन, टेक दिस क्वेश्चन. Come on, read the question. Read the question. चलो चलो चलो. Okay. Good question. Determine the angular velocity of link BC. दिख रहा है सर आपको? मैं बताता हूँ सर, एक्चुअली ये कैसा है. I'll show you. Don't worry, sirs. Don't worry. Sir. Must question है sir. Expected question. ठीक है. These are all very good questions, sirs. Right. O R, this is written clockwise, 2R R B C A B C. A, यहाँ पे भी पिन है सर, पिन. एक सेकंड. ठीक है. Now, this is actually rotating at omega. This wheel. This length is given as R, this length. And this length is given as 2R. This length is given as R. Let me check once. It is OR, 2R, R. ठीक है, sir. What is the question? What is the question? Determine angular velocity of BC link. He wants the angular velocity of this BC link when case 1, the center of the disk is fixed, pivoted, while in case B, disk rolls without slipping on the horizontal surface. In both cases, the disk has a clockwise angular velocity. Okay. देखो क्वेश्चन क्या है मैं समझाऊंगा. There is a disk. It is fixed about point O. There is a disk fixed about point O and it is rotating in the clockwise direction. यहाँ पे एक पिन है and it is connected to this link AB and it is fixed here and ये यहाँ पे घूम रहा है सर. He is asking when this rotates about the fixed point O, when this rotates about the fixed point O, what is the angular velocity of link BC? ठीक है सर. एक काम करते हैं सर. You tell me, my dear students, what will be the velocity of this point B with respect to C? Definitely, इस ये तो वर्टिकल है, it will be perpendicular. It will be perpendicular only. It will be perpendicular only. इस लाइन को perpendicular होगा velocity of B. Similarly, as this is rotating clockwise, तो यहां पे topmost point पे what will be the velocity of A? It will be to the right, tangential होगा. So if I write the velocity of A, थोड़ा ये कलर चेंज करेंगे रे बाबा. देखो, so what will be the velocity of A? It will be like this, sir. ठीक है. So if you see the link AB, so along the link AB, my dear students, एक बार इसको हम ये ले लेंगे. If you take link AB, this is link AB. So as this is rotating clockwise, ये तो connected points है, तो what will be the velocity of A, the topmost point of this circle, the disk का, so r omega, ये r है, इसका omega is given as omega, तो what will be the velocity of A, so it will be, देखो इसको tangential होगा, इसको tangential, how much will be this, it is r and this is omega, so it will be velocity of A will be r omega, where omega is the angular velocity of this disk and r is about this point it is rotating, about this point it is rotating. Very good, sirs. Now, will there be any relative velocity along the length of the link? No. Along the length of the link अगर यहां का velocity r omega है तो यहां पे क्या होना चाहिए sirs? This should also be r omega only, because there will not be any relative velocity along the length of the link. तो ये velocity b का आ गया sirs. So what will be the velocity of this point b? It will be velocity of point b can also be written as r, ये वाला r into इसका omega. What is omega of this? मान लो इसका omega bc है, omega bc. I repeat sirs, सुनो carefully. Along this the velocity is r omega, iska about this point A it is rotating about this point r, and omega of this disk r omega, va r omega. But along the length of the link, as it is a rigid link, if this is velocity along the length as A, if B पे भी उतना ही होना चाहिए sirs. So this is the velocity of B. But velocity of B can be written as, because as it is rotating about point C, it will be r into this omega of this BC, omega of BC. So r into omega of this BC. This is velocity of B, this is velocity of B. Equate करो. R omega BC is equal to r omega. तो r कट गया. Omega BC is asked, that is equal to omega only. In which direction? अगर ये ऐसा घूम रहा है तो ये इधर जाएगा, तो after some time it will be somewhere here, so it will be counterclockwise way. It is counterclockwise. ये पहला केस है सर. This is the first case. Now he is asking the second case. अच्छा है सर, second case. What is the second case? The second case is this. एक second. Let me do the second case. So in the first case, the answer is omega clockwise. The answer is omega clockwise. ठीक है. Let's go to the second case. In second case, what he says is, देखो एक बार. It is in disk is in pure rolling. पहले केस में it was fixed about the center and it was rotating about some fixed point. Now it is pure rolling. देखो about this point. It is rolling without slipping. अब ये roll कर रहा है without slipping. Must question है सर. Again this is A. Again this is B. Again this is C. He is asking if it is rolling without slipping and the omega of this disk is given as omega only. देखो एक बार second case में इस disk का omega clockwise. Okay, ये R, ये 2R है, ये radius R है, ये R है, ये 2R है सर, ये length 2R है और ये R है सर. How do we do this? You know very well, whenever it is under pure rolling, at the point of contact is the instantaneous center. It means as if this complete disk is hinged about this point and it is rotating. It's something like this. अगर वो pure rolling में है, तो this is something like your instantaneous center. As तो ये लेंथ कितना होगा सर? डिस्क इज रोटेटिंग विथ ओमेगा, सो ये रेडियस कितना, रेडियस इज r, तो दिस लेंथ विल बी 2r. तो व्हाट विल बी द वेलोसिटी ऑफ द टॉप मोस्ट पॉइंट? इट विल बी r omega. So when it is in pure rolling about this point, it is at that instant it looks like, it seems like as if the complete disk is rotating about this as if. So therefore about this point it is completely rotating. So what will be the velocity of the topmost point? ये r है, ये भी r है, तो 2r. So velocity of the topmost point A is equal to 2r omega. Excellent sir. If you catch this point, the problem is solved. So the velocity of point A is 2r omega. बहुत बढ़िया sir. So velocity of point A is, now let us take this link. This is A, this is B, and the velocity of point A is 2r omega. What is omega? It is the angular velocity of this disk, angular velocity. ठीक है sir. So along the length of the link, relative velocity तो 0 होगा. So अगर ये 2r omega है, ये also 2r omega ही होना चाहिए. At this instant, this is in pure translation. क्योंकि देखो at this instant. So what will be the velocity of this sir? What will be the velocity of this? अगर ये ऐसे घूम रहा है तो ऐसे रोटेट होगा. Let omega of this be omega bc. What will be the velocity of point B sir? velocity of point B, it will be equal to R, iska R, into omega of BC. So this is velocity of point B, this velocity of point B, equate karo. So R omega BC is equal to 2R omega. तो R कट गया, ओमेगा BC is equal to 2 ओमेगा. ब्यूटीफुल क्वेश्चन सर. अगर ये क्लॉकवाइज ऐसा घूम रहा है तो ये इधर जाएगा, तो थोड़ी देर में ऐसा इट विल बी काउंटर क्लॉकवाइज. एक्सेलेंट सर, एक्सेलेंट. नाउ लेट अस टेक